Welcome back. This is a really big Olivetti. So yeah, Olivetti certainly weren't mucking about when they brought this thing to market in 1986. Their personal computer M280. This thing features an Intel 286 clocked at 12 megahertz. There should be 1 megabyte of RAM in there and potentially a 20 megabyte hard drive. This machine only has the 3.5-inch floppy drive. There obviously would have been an option at the time to fit a 5.25 drive in there, but just look at the size of this case. Even the keyboard that goes with it is comically large compared to other keyboards of the time. The only thing normal about this is the monitor. That is a green phosphor monochrome display, and that is a 12-inch screen. Sitting on top of this, that almost looks like an 8-inch screen. It looks so small in comparison to the PC. But this desktop, well, measuring about 18 centimeters or just over 7 inches tall, this is certainly the biggest personal computer box that I have ever come across. But we'll put the keyboard and monitor to the side for now, and that will allow us to have a closer look at the system itself. So we've got the two drive bays there on the front, a rather satisfying power switch just below them, row of LEDs there with a reset button hiding in between. There's a key lock there, presumably for the keyboard, and even volume control, which, well, it can only really be for the PC speaker. Nothing much of interest on the sides. On the back of the machine though, we have this rather beefy looking fan. There's our power input and output that will supply the monitor. This 9-pin connector down here, well, that is actually for the keyboard. On this side, we've got printer and serial ports. And then there's one card that we can see exposed here. That is for the screen. And that monitor just has an RCA jack on the end of it, and we'll need to figure out which one of these two we have to connect that to. One thing that you might pick up on here is that those ports, they're upside down. And there is a reason for that, which we will get to shortly. But in the first instance, I want to take the top cover off, and there's something you don't see very often on a PC. Flat-headed screws. That in itself shows the vintage of this machine. So there's just the 3 screws along the back here that are holding the top cover on. And removing that reveals another expansion card. This is our MFM hard drive and floppy disk controller. There's our display adapter in the background. The disk controller is sitting into a 16-bit ISA slot, whereas the display adapter, it's just into an 8-bit slot. There are various other slots free there, so we will have some room for expansion. Well, if of course this thing works. And check out this power supply. Made by Alitech in Italy, as you would expect. After all, Olivetti is an Italian brand. I don't think I have ever seen a power supply in a PC before with such heavy wires running to the motherboard. That black wire is obviously our ground. That red wire is carrying 5 volts. These two rather thin wires beside that then, well, they're just carrying 12 and negative 12 volts to the motherboard. But this here, these two, this is definitely a first on me. It does have the obvious Molex connectors that's providing power to the floppy drive, and you might just be able to catch a glimpse there of a rather beefy looking hard drive sitting in the bottom of these drive bays. And while I said that those wires are running to the motherboard, well, that big green PCB on the bottom there, it is looking rather sparse, isn't it? Not an awful lot going on here other than our ISA slots. There did used to be a battery in here. It was connected at that point at one time, but when I got this machine, that was the first thing I removed, and luckily it hadn't leaked whatsoever. So no battery corrosion to deal with for once. But going back to that board and the sparseness of it. Well, this ties in with those ports on the back that I said are installed upside down. And that's because if we remove these two screws, that allows this bottom section of the case to come off, revealing our motherboard. I really hope this works, because troubleshooting this thing, it would be an absolute nightmare. But before we jump in and start throwing power switches, the first thing I want to do is strip this machine down, just so we can give everything a really good clean. It is rather caked in dust. So let's take it apart, clean it all down, and while it's in bits, we can have a closer look at the hardware. Oddly enough, despite there being plain head screws on the outside of the case, all the screws inside are your typical Phillips head. And there's the first problem I have spotted straight away. We have a blown tantalum on this display card. That's it apart, and I have given it just a very quick clean to remove any of the loose dust. So let's take a look at what we have. Well, the motherboard, and there is our ISA backplane. Those are linked by this little card here, but also a cable that runs between those 2 points. This is the first motherboard I have that has this type of CPU socket. And there is our Intel 286 12 MHz chip. I love that package. First one I have seen myself, but something very funky about that compared to just your typical CPU with the pins on it. And this is keyed compared to, your CPU with the pins of the era, which generally wouldn't have been. There's a notch in 3 of the corners there, and just a solid corner there. The solid corner goes up against a little pin on that side. CPU sits into its socket, and then this heat spreader goes on like that. Presumably this is built up here to make contact with the bottom of the case, just to help dissipate any heat. The rest of the board then is mostly just 7.4 series logic, and these larger ICs are doing various computery tasks. These are the DMA controllers, interrupt controllers. I think that's a timer. I did look all this up, but I have forgotten it. That is doing the I/O on the serial and parallel. Can't find anything about this Faraday chip. Presumably it is also talking to one of these ports. That would be our keyboard controller. That is the real-time clock. There's our 2 BIOS chips, PC speaker, and this here is the onboard memory. 256K by 1 byte. 1, 2, 3, 4, 5, 6, 7, 8 of those plus 1 for parity. So 256, 512, 700 and something, and 1024. That is our 1 megabyte of RAM. So as I say, I really hope this works, because chasing any faults on this around all this logic, while it is totally possible to repair it if there is a problem because of, it's all discrete logic, it will take forever and be a bit of a nightmare. Plenty of bulge wires from the factory, isn't there? Our MFM controller card then with a floppy interface as well. This is a Western Digital card from 1985. Oh, I did say earlier that this was a 1986 machine. And while it does seem correct that Olivetti brought the M280 to market in 86, this board is labelled 87, and it is a revision P2, so perhaps just a later revision from what was released originally. But yes, our MFM and floppy drive controller. Pretty standard affair, just a full-size ISA card. That jumper on it there is for the hard drive activity LED. And then our display adapter, which I think is an EGA card, certainly going by the Paradise 38315B chipset that is on it. It does have that blown tantalum, but it also has a rather wobbly RCA port there for presumably the monochrome output. Looks like someone has attempted a repair here before. We have a little wire repairing that trace that has obviously been broken, and a big nasty solder blob there as well. But I think that must have came loose too, because the actual port itself is sort of just flopping in the breeze, as a certain other Australian YouTuber might say. Haven't been able to find this exact card online, but certainly there are plenty of other examples very similar to it. And our dip switches here with just number 3 turned on, well, that would be setting this to a monochrome output, which would certainly be correct given our monochrome monitor. Over here then we have the 2 drives and the power supply. The hard drive is a half height 5¼ inch Seagate ST225, and this is indeed a 20 megabyte MFM hard drive, which seemingly had no errors from the factory. There's nothing written here in the error map. The floppy drive then, it is a 1.44 megabyte Sony drive, and I do hope this works, because it wouldn't be the first time I've had a Sony drive that has failed on me. And speaking of things with problems, the power supply, I found an issue in this, because if we take the multimeter, which is in continuity, and what led me to find this was that blown tantalum on the display adapter. After I seen that, I started looking for shorts, and I have found one within the power supply. Because if we look between positive 12, which is there, and ground, you can see that is essentially a dead short. Now between ground and 5 volt, well, this thing still squeals at you, but it is reading 50 odd ohms there and climbing, so I think that is fine. Between the positive 12 and ground though, that is far too low, and in fact it is dropping there. So there is a problem within this power supply. We'll need to get in there and take a closer look in a minute. Some good news though, I did find the original battery that I pulled out. 6 volts worth of batteries. Obviously this is dead, but we'll need to come up with something new to replace it. I did take this out of the machine, but I hung on to it just to keep the original connector. We can reuse that and stick new batteries on the end. And then if we turn through 90 degrees again, you can see the monitor, which has taken quite a bit of yellowing. Other than that though, it does seem to be in fairly good condition. I haven't tested this either, so no idea if it works. But it is a monochrome display, as I said, and just has the one input on it. And below that then is the keyboard, which despite its age really feels just like rubber domes under here. I don't think those are mechanical switches, and it feels pretty nasty to type on, if I am being perfectly honest. The other rather nasty thing about it is this lead. Look at the state of this. The rubber on this is just disintegrating as you touch it. So this is way beyond saving, and we'll need to come up with something to replace it. The keyboard connector veers away from the standards in a similar sort of vein to that power supply. Rather than your AT or PS2 style connector, it is using this 9-pin D sub, but with only 5 of the pins occupied. So I'm going to need to find some sort of replacement cable with at least 5 cores. In fact, I'm going to need 6, because we're going to need a ground between the keyboard and the PC. So we have a couple of things that we need to fix: the power supply and the display adapter. I think we'll start with the PSU though, as that is pretty critical to the operation of the machine. You can always replace this if need be, but this is a bespoke unit to that Olivetti, so let's see if we can't get this up and running. I mean, worst case scenario, I could probably hack in the typical AT power supply and just use that, but I would rather have this original PSU in there. So let's see if we can fix that short. And one other thing just to touch on very quickly, we get positive 5 volts, positive and negative 12 volts out of this. But what about negative 5? You're going to need that for your PC. Well, that is generated on this board just here. Let me take this apart and see if I can figure out what's gone wrong. Power supply, and I think I have found the problem. In fact, I'm fairly confident it is this electrolytic right here is shorted, but let me show you how I came to that conclusion. So, power connector down here, we have a short between 12 and ground. If we turn over to the other side, that is the underside of that connector. You can see the large trace running down here, that is the 12 volt line. Its first port of call is this point, which is just a jumper wire running across to here, which comes up to there, and there's another jumper running over to here. And all that's doing is connecting that 4-pin connector to this 4-pin connector. But 12 volt line continues up this road here until it comes to this point, which is a 100 ohm resistor. It continues on up here as well to this point, which is presumably a 75 ohm resistor. But because our short is reading a dead short there, 0.06 ohms, 0.5, well, we know it's not beyond this point. If it was, it would be reading either that 100 or the 75. So following it this way, first point of call for it is this component, this here. Now I'll be honest and say I'm not 100% sure what that is, but removed it from circuit and it's fine, it's not shorted. Next point of call then is this capacitor, but again removed that from circuit, it's not shorted. Continues up here, runs through this small coil, which would read as a short anyway on the multimeter. And then that makes its way up to this point, which is that capacitor. And if we remove that from circuit, and if we test this out of circuit, you can see that it is shorted. 0.05, that is the same as we were seeing on the power supply. If we bring that back over and check for the short again, well, it's gone. It's now reading about 167 ohms, which again is probably right. So this must be the problem. 4716. I don't have an exact match, but I do have a 4725 volt. 16 volt is maybe a bit close to the 12 volt, isn't it, of that 12 volt rail. So definitely won't do any harm sticking in this one instead. Just need to double check I'm getting the orientation of that correct. That side there should be ground, and it is, yeah, that's right. So solder that on. We'll reassemble the power supply. I didn't find any other problems within it, so hopefully it was just this. And yes, I probably should come back and, you know, replace those other 3 at least, just because they're the same type. And if this one's gone, well, it's probably only a matter of time before they go as well. In fact, maybe it wouldn't do any harm just to recap the whole thing. But I definitely don't have these other ones in stock, so we'll just fit that for now. We can test it, and hopefully the power supply comes up. Power supply is back together and in the case, and that's just so I can hook up the power switch at the front via this. Probably could have jumpered it locally, but better just to hook it up properly via the switch. I've added these 2 old hard drives here just for a bit of load. Don't want to run the risk of using the Seagate drive that came with this machine, just on the off chance this is putting out silly voltages and would fry anything. These 2 drives are pretty much useless, so I'm happy enough if they explode. It is what it is. But let's see what's going to happen. Will it work? Will we get fireworks? Power on. Hard drives are spun up and the fan is running. Let's test our voltage rails. Just do it on this Molex connector here. So 5 volt first of all. And it's reading about 5.2. That's a little bit high. What about the 12 volt? It's only 11.5. So things are still a little bit out of whack there. 5.2. That is a bit high for my liking, you know. There is a little screw here. Just let me see if I can maybe adjust the voltage rails down a little bit. Get that 5 volt closer to 5. So the little trim pot I was adjusting there, it is just at that point. I turned it down quite a bit, which has brought the 5 volt down. It's now down to 5.08, which is still a little bit high, but definitely better than 5.2. The issue might be though that it has also reduced the 12 volt rail. It's now down to 11.1, which is a little bit low, but all we can do is try it. I think what we really need to do is recap the rest of that power supply. That should hopefully stabilize these numbers a bit. But I think it's fine for now. Although before we can reassemble the machine to see if it works, we're going to have to fix that display adapter. So we have 2 problems that we need to fix, the tantalum and this port. Now hopefully we can repair this. The tantalum on the other hand, that'll have to be replaced. And of course, I don't have the correct value of tantalum in stock. It's a 106 or a 10 UF. What I'm going to try and do instead, just as a temporary measure, is replace it with a 10 UF 25 volt electrolytic. That should be fine in there, just for, you know, the few minutes that we're going to be testing this machine with. I'll order the correct part to replace it at a future date, but for now, let's get that off and get a better look at what we're dealing with, especially over here. Right, I fitted our temporary capacitor. I will order the proper tantalums, but the electrolytic will do okay for today. This, on the other hand, well, this is well and truly mangled. Only the signal pin remains on it. The ground pin is missing, and there should be 2 little supports at the front here as well that go into those 2 holes. They're also missing. The via that goes through the board here where the signal connects, it's missing. The pad is missing on this side, although there's maybe just enough of that pin sticking through that if we can't get this securely mounted, I can make something off between there and the trace beside it. But for mounting this, well, I've got an idea. And what I want to try and do is take the leg of an old component, heat this up and just melt it into the plastic here to create the new pins that mount it to the board. Equally, we'll try and do something similar with the ground. Maybe if I can bend that up a bit Yeah. So if I bend that up a bit, stick this through there and twist it into position, try to drop a bit of solder onto it, maybe it'll just be enough. Right, I'll have a play with this, see how we get on. So that seemed to go okay. I have the 2 pins melted into the plastic here, just to act as supports. I connected that one there to the ground. So that should fix that. Let's see if it fits. Yep. Seems to fit okay. And you'd never know from this side. Let's just see about soldering up those first 3 points anyway. Then we'll have a think about how we're going to deal with that signal. This is going to be quite hard to solder, isn't it? Because that's all onto the ground plane there. And that is a really thick ground. Yeah, let me turn my temperature up. That is pretty good. And that is, yeah, it's not bad. Stable enough. As long as we are gentle putting the cable in and out. Get a bit better as well when we make off that. And speaking of which, all I'm going to do here for this, I think, is just jam a leg of another component down in beside what's left of that one. We will scrape off part of the trace adjacent to it, just bend it over and solder it onto it. That will help to add some rigidity rather than just using a wire. Just going to put a little bit of flux along that just to help it float. And hopefully that'll be it. Yep, that's connected okay. But just to be sure, so if I stick that up in there, should have continuity through to there. And we do. We should have continuity between the 2 grounds. We do. Let's just check that nothing's shorted. Nope. That is fine. I'll just tidy all this up a bit. Then we'll reassemble the computer, throw the switch, and see what happens. Everything is back together. I've just left the top cover off, so if there's any fireworks, we can see them. Monitor is hooked up, as is the keyboard. Let's see what happens. So hard drive spins up. Does the monitor come up though? System's making all the right noises. There's a floppy drive seek. So I dare say the computer is starting, but we're not getting anything on the screen. We'll play with the contrast. Oh, there we are. That is the brightness up full. My goodness. This screen must be kind of tired. Keyboard seems to work. Number lock is on. Caps lock comes on, as does scroll lock. And it's telling us on screen we have a non-system disk. Strike any key. Well, spacebar works. Just need to remember how to get into the BIOS on an Olivetti. And just before we close up, I have now fitted a battery pack down here. Just a dual CR2032 battery holder to give us our 6 volts and match what the original batteries were putting out. No requirement to have a diode in line with that. The original batteries were non-chargeable anyway, so the system obviously isn't trying to charge these. And you might notice down in there, our little fix on that monochrome output. That did not last very long. Snapped off the board on the underside on me. So I've repaired that again, and this time put a lot of hot glue around the connector up here just to make sure that it stays put. It is a lot more secure now, even if it does look a bit of a mess. I really don't like working with hot glue, but there is nothing else for it really, other than replacing that port. And I'm sure you're wondering, what about those voltage rails? Since everything's connected now, has that 5 volt maybe dropped a bit? You know, could we tweak that little potentiometer back up a wee bit? Let's find out. And if I leave that there and be very careful then not to short anything. Now the 5 volt is sitting at more or less 5 volts. The 12 volt is a little bit low, but well, it seems to be okay and everything's running. But I think I will order up the caps we need to just fully recap that power supply. Certainly won't do any harm anyway, and I need to order the replacement tantalum for that display adapter anyway, so may as well just get it all. And you may have noticed that the system now boots to its hard drive. I managed to get the BIOS set up. There is no keyboard combination to get you into it, rather you need to use a little bit of software. Now, I wasn't able to find the original Olivetti software. In fact, I can't find any of the original software that would have came with this machine. Just doesn't seem to be out there. But handy little tool that was suggested to me, G-Setup, that allowed me just to set up the details of the BIOS. Type 2 hard drive, so selected that and it booted into this. Sherwood Systems, that seems to be the name of the company that originally sold this machine. And we have a very simple menu system here. Microsoft Works, format 1.44 megabyte disk, format a 720k disk, or ship heads on hard disk. I assume that means to park the heads on the hard drive. But that is it. There isn't really anything else on this machine. There are a few documents in there within Microsoft Works, a few essays and things that people have written, but all personal information, and I'm not going to show you any of that here today. So it does leave us with a bit of a blank canvas going forward. What else could we add to this machine? A bit more memory would certainly be good. There's only that 1 megabyte on the hard drive. And I do have a bit of an idea for how to add some more RAM to this. But that will have to wait for another time. This video is long enough as it is, and we still have even more work that we need to do to this little machine before we consider putting in any upgrades. I want to change those capacitors on the power supply, and we need to sort out that cable going to the keyboard. It is disintegrating as we speak, leaving bits of sticky rubber all over the place here, so this has to go. I do want to keep the coiled effect though, so I'll have to find a suitable replacement from somewhere. There's bound to be something out there on eBay that I can hack apart to make work with this. But for now, the big old system is up and running. You have no idea how happy I am that it works. I was dreading a potential fault on that motherboard, but no, it's working well. So I think we can call that a success for today. One Olivetti M280 up and running. Bit more work to do next time, and then we'll maybe add a few upgrades after that. But that is it for this video. So if you enjoyed what you've seen, I would appreciate a big thumbs up. Why not hit subscribe if you haven't done so already. Still plenty more yet to come here on CRG, and I'll see you next time.